this, and they appear in your algebra text and quizzes and tests the entire year. Okay, this is very important. So when you read a problem, you can annotate on top of that problem with the actual statements. What number? I don't know, write N or X. Increased. Add, right? Good, good. Plus by 1/2. Okay, I'll actually see 1/2 of what? Itself. That was what? X equals 54. Now we'll do it again. I did it for you a couple of days ago. This is the major problem that students have. Instead of writing this, they will write what?
They forget to put the X.
Yes, they will write X plus 1/2 of nothing. Just 1/2 equals 54, right? Kids who know me, you know how many times you made that problem, that mistake. No, 1/2 of itself. Sometimes you will have a problem, a number increased by 3/4 equals, but it says by itself. What's that self? That's the same X, okay? Let's move on. Let's solve it. What is the other way to rewrite 1/2 X?
X over 2.
Never do decimals with me. They frustrate me. They repulse me. X over 2 equals 54. We will bring them to the common denominator of 2. Okay, how do we do that? Does that ring a bell?
Yeah.
We're just kind of getting into the groove of remembering everything that we studied last year, right? You're supposed to be writing. Okay. So that will become 2x over 2 plus x over 2 equals 54. Next step, Kareem. Can you add them now?
Yeah.
You can. You have the same denominator, so that's what's happening in your head, right? Some of you already calculated. That's awesome. Good job. That's why you're so brilliant in math. So what's happening, Kareem? Next.
You add 2x plus x.
And you have?
And then 3x over 2.
3x over 2 equals 54. I see division, so I will probably solve this by multiplication. Or I see the 54, I can do 51 over 1, and I will solve it by using cross multiplication. Very, very nice. I want Nay to cross multiply. Ha! Ha! That's what you do.
3x equals 108.
Yeah. 108. And x equals somebody?
36.
36. Good. So that is your number. Can we pause here for a second? Keep rolling, Nadine. So if you have 3x equals 54 multiplied by 2, right? Are you there with me? Remember, when we have an equation, if I multiply both sides of the equation by a number, I am, I'm just increasing it. I'm correct. Nothing changes. If I reduce both sides of the equation by the same number, I'm also fine, right? What if I decide to divide both sides of the equation by 3? Is 54 divisible by 3, Juliet?
Yes.
Huh? Hmm? How do you know? Oh, this precious video time, huh?
It's 18.
How do you know that a number is divisible by 3? Vlad?
Multiplication table.
No.
If the sum of its digits is divisible by 3.
Thank you. If the sum of its digits, you didn't know that, you write that on your arm with a Sharpie. If the sum of its digits is divisible by 3, it is divisible by 3. So my sum is 5 and 4. It's a 9, so it will be divisible by 3. Those of you who didn't know this rule, welcome to magic of math. So if I divide this by 3 and this by 3, I don't need to divide 2 by 3, at least something, I can divide 54 by 3. So that is already my x, and that will become 18, 18 by 2, 36. Why do I do that? Jasmine remembers that sometimes we'll have things like this, 3 by 4, by 5. X equals 45 multiplied by 9 multiplied by 6. You know what kids do? They multiply. Why? I mean, because we're collecting terms. Let's say that is a hypothetical scenario. You have something like that. Why? Reduce. Like make it smaller like this. You can reduce this and this. It'll become a 9. You can reduce this and this. That's a 3. That's a 2. That's a 3. 2, 2. Okay, you don't have anything. So 2x equals 9 by 9. 81 over 2. Does this make sense? When you have large numbers but they're split, before multiplying it and making it 108, see if you can make it smaller before going bigger, right? See if you can reduce it. Done.